Welcome to Chantex Multimedia, streaming live to your device all the way from Brisbane, and it is wonderful to have your company this morning. And as promised, today we have a very special segment coming up, and that is when we connect with GOPIO Manhattan for a very special conference on COVID-19. So let's cross over to Manhattan.
Which connects not just with people here in this city and this state, but across the world. And the more we do things on COVID-19, the better it would be for all of us, for the entire world. So I deeply appreciate these initiatives. I also would like to once again thank GOPIO for taking lead in giving us a helping hand in dealing with the pandemic. When the pandemic was raging at its high last year, you came in support of students, of community members, of young ones, of old people, distribution of food, distribution of medicine, facilitating people's travel. All that is truly and deeply appreciated. Grateful, I thank, we have a very distinguished speaker today, Dr. Hannah Axelrod, and I really look forward to her wise words as to how we can deal with this pandemic, what are its projections. To me, it seems that we are pushing the pandemic away with the vaccinations that are going on here in this country, in India and other parts of the world. But at the same time, the news that we get on mutations, on the vaccine trying to change itself is a cause of concern, not just for us, but everybody in the world. Let me also take this opportunity to update you as to what we are doing in India. We have, as of today, approximately vaccinated some 13 million people. In the first phase, we vaccinated our health workers and then the frontline workers. And now we have taken a decision to open up private clinics along with the government clinics for vaccinations. So you'll see a major jump in the numbers of people who are getting vaccinated in India. We have actually added a huge capacity to the already government dispensaries and government network clinics that were doing the vaccination. On the international front, let me tell you that we have supplied COVID vaccines to over 30 countries. And we have so far supplied some 36 million doses of vaccines around the world. We have also made a deep commitment to the WHO COVAX facility. And under that facility also, we've started working. Few days back, you would have seen Prime Minister of Canada spoke to our Prime Minister and he made a request for 10 million doses, and we'll be supplying Canada 10 million doses so that they're able to effectively vaccinate some 1/3 of the country. So, all this that we are doing in the spirit of cooperation, in the spirit of sharing our resources, in the spirit of treating the whole world as a family, it gives us a lot of satisfaction and a lot of strength a very strong sense of oneness, of belonging to the world, and we feel proud about it. I'm sure this pride will also be shared by people of Indian origin, American Indians here, and people of Indian origin across the world. With that, I thank you very much once again, Madam Samant, and Sofa, Dr. Thomas, and other members for inviting me to this evening's conversation. Thank you very much.
Thank you so much, Constantine Jaswalji. What an encouraging statement you made it. I think this is such a wonderful thing to hear coming from lion's mouth. You are the lion, a leader. Very encouraging. Thank you so much. Without wasting any time, I have next person to invite, and I think everybody knows him. Who is he? GOPIO Chair, International Council. Thomas Abraham, everybody knows him. Thomas Ji, we would like to hear your comments and a few words. Please welcome Thomas Abraham.
Thank you, Dr. Asha Samant. Asha Samant is our international coordinator. Welcome everybody, good evening, and Honorable Counsel General Randeep Kumar Jaiswal, our distinguished speaker, Dr. Hannah Axelrod, GOPIO Manhattan President, Shivendra Sofet, and the Executive Committee members, ladies and gentlemen. I bring greetings to you from GOPIO International and as advisor to GOPIO Manhattan. It's good to hear from Ambassador Jaiswal about the things which are happening in India. India has done a great deal of service to the whole world. In fact, they have supplied COVID vaccine to 33 countries, while USA and Europe and other countries have still not supplying them, but we came forward. That is a great thing which our Indian government has done. It is almost reaching one year since we are all homebound, and our New York area was the worst hit in the first half of last year. The country as a whole is still coming out of its peak from last month in coronavirus infection and death. Since the vaccination has got started in December, this webinar by Dr. Axelrod is very timely. Thanks to Dr. R. Arnab Ghosh for taking this initiative of organizing the webinar series on the health issues for our chapter, and we had a highly successful one on January 15th. And thanks to Dr. Asha Samant for putting together today's evening program. For those who are not aware of GOPIO, GOPIO International is a pan-Indian community organization for NRIs and PIOs with 100 chapters spread in 35 countries. It was formed in 1989 by the National Federation of Indian Associations, whose president is also joining us this evening, Mr. Ajay Dubey. Although GOPIO Manhattan got started only in last September, the chapter has done several programs in the short period. It is a pan-Indian community platform for those who live in Manhattan or work or do business in Manhattan. We welcome you to become a member. As a new initiative, GOPIO Manhattan has now started a new program that is community feeding in cooperation with Interfaith Services. At the Tompkins Square Park, one can participate as a volunteer or become a sponsor, or our president, Shivendra Sofet, will give more information after the webinar. Now, I also wanted to recognize some of the presence of some of the community leaders here. We have Mr. Lal Motwani, our international coordinator, who has headed many groups like NFIA and Society of Indian Engineers. And we have our Vice President Ram Gadvi, and International Coordinator, you already met Dr. Asha Samant, and then our Media Council Chair Nami Kaur, and our Associate Secretary Jaswant Modi, and our Treasurer Keval Kanda. And I also see GOPIO Central Jersey President Patsy Leopold. And then from Australia, Brisbane, our Chair of Human Rights Council, Umesh Chandra, who is streaming it all over Australia and New Zealand and Fiji and other places. So we have an array of international leaders of the diaspora community. And thank you all for joining. And I'm sure this seminar will be a very timely and useful to all of us. Thank you, and back to you, Ashaji.
Thanks so much, Thomas. You always say the things which everybody needs to be remembered. Thanks for recognizing all the GOPIO members who are there. That shows that we are all together. When I need to, we listen to the good things and share the things. Thanks, Thomas, once again. Before I invite our speaker of the day, I would like to say there are a few housekeeping things. She is a solo speaker. We would give her a time to finish her 35-40 minutes whole thing. At the end, the best friend, Dr. Ghosh, will be the moderator of the day, and he will convey, and all the questions will be answered. So have a patience and give her a time to listen to her. Let me say just a few words. Dr. Axelrod's credentials are very heavy, but Hannah, I'm going to say a few words. First thing is, you are MD, MPH. You're an assistant professor of medicine in the Division of Infectious Disease in the Georgetown, Washington University School of Medicine and Health Sciences. You completed your internal medicine residency in Portland, Maine. After that, you came in a fellowship in George Washington University and MPH from Yale. What a pride, woman. You are a pride of womanship also. And you're also a founding director of George Washington COVID-19 Recovery Clinic. And you're also an investigator on multiple COVID-19 research studies. Without wasting my time or yours, here I present. And people, there is Dr. Hannah Axelrod. She's going to speak COVID-19, vaccine, and what is the future. Welcome, Hannah.
It is my absolute honor to be here. Thank you so much, Dr. Samant, for this kind introduction. I am going to load my slides. Forgive me if this takes a second or two. But what I would like to share, what Dr. Samant did not know about me is I have immigrant parents and I grew up in the diaspora. My family is originally from Russia. We left when I was 6 years old. We lived in Israel for several years and then moved to the USA. And I have become one of the acceptable professions for immigrant children, which is doctor, and my brother is an engineer. But I did not grow up in a medical family. And I say this because some of my challenges throughout this pandemic have been not only to communicate and explain science to people in my field in infectious disease and medicine, as well as to my patients, but also to the people I grew up with, who primarily speak a different language and who primarily don't share my scientific detailed knowledge. So I thought about that when I was putting together this presentation. I would like to share what I know of COVID-19 with a focus on my professional experience in the US in the past year. And at the end, I would like to have a conversation about what the implications are of our experience, how it varies around the world, and what we all need to do to come out of this pandemic, to not have another year like what we just had. So thank you so much for this opportunity. I mentioned my experience at GW, and to tell you about my life before GW for a minute. Before medical school and residency and medical practice, I come from a public health background. I originally started after college by working for Partners in Health, which is a global health group based in Boston, which focuses on treating HIV and tuberculosis in very low-income settings around the world. And I was inspired to learn medicine and be more hands-on about treating infectious disease. But I always had this background of thinking beyond the hospital. And in COVID-19, one of the reasons I have had such broad experience in the past year is I was one of a few physicians at GW with this kind of background when the pandemic hit. And I had spent additional training at Yale, specifically studying epidemiology of microbial diseases and public health actions that might prevent or stop a pandemic. So I had not been at my clinical and teaching job for very long when I had to remember all those lectures from graduate school and think how we can put them to use. At GW, we are a university with 30,000 students, multiple professional schools, including international studies, law and medicine, and health sciences. We do not only teach medical students, but physician assistant and nursing students as well. We have a 370-bed hospital located in the heart of Washington, D.C. We are 1/2 of a mile away from the White House and a mile away from the buildings of U.S. Congress. And that location also defined our experience, because when we thought about who we need to protect in a pandemic, we started with our own employees. We thought then about our students and faculty, and we shut down the university and the medical school in spring and kept it shut for many months. We are only now starting to return students to campus in smaller groups. We then thought about our service to the DC community. We were the major testing facility aside from the DC public health labs, because we were able to use our molecular testing capability at the university and hospital to adapt our molecular testing technology based on the test that the CDC developed last spring but did not make enough of. We essentially made our own version, validated it within our samples, made sure it worked as well as the gold standard test, and then started testing thousands and thousands of residents of DC. We had some people in the School of Engineering. In the picture in the middle, this is actually Professor Desti Provenzano, who is married to Dr. James Rao, and together they made a reusable N95 equivalent mask in case we ran out of PPE. Now, we were blessed not to run out of PPE, in part because of the work of our emergency medicine division, which includes many experts in disaster management. I mentioned our location in Washington, D.C. We provide some of the safety and emergency support for large events in D.C. And
He's a doctor. She's
thinking on a large scale. And since the pandemic subsided, we started thinking about how can we be of service to the business community. So our emergency medicine group also consults for reopening support services, in which they help businesses and other groups think through a strategy for reopening with minimum number of outbreaks. And finally, over the summer, we realized something very disturbing about our patients who survived COVID-19, which is that many of them, at least 20%, were still having symptoms 2 months after their diagnosis. And this included both patients who had been severely ill and in the ICU, and that was perhaps not surprising. But what was surprising is the young and healthy people who had moderate severity of disease who were not coming back to their normal health. So we opened a clinic in early fall, and I had 2 colleagues who were brave enough to take this on with me, an immunologist, Dr. Chang, and one of our leaders in internal medicine and primary care, Dr. Lipson, who is, I understand, actually going to Columbia University in New York next. But the 3 of us devised a plan for how we will figure out how to help patients get better, even though we don't have all the scientific answers on long COVID. And in part, that work was inspired by what Mount Sinai Hospital was doing in New York City. I went to medical school at Mount Sinai and was speaking with them in setting up some of this work. So that is the experience throughout the pandemic. My disclosures for conflict of interest are I am a co-investigator on several sponsored trials, including vaccine trials by Moderna and Sanofi and an antibody infusion study by Regeneron. I have no financial investment or personal investment, and while I occasionally get speaker fees, this has not been a major source of income. I will include some data that is preprint, meaning it has been released but not yet gone through full peer review by scientific juries. I have to do this every time I give a talk on COVID-19 because the science moves faster on this virus than some of our review mechanisms. However, there have been papers on COVID-19 that were pre-released and turned out to be not quite as advertised. So I do share when my information is not fully printed. And what I would like to accomplish today is give some of the background for our experience here. I focus on the US as this is what I know best, but many of this translates across borders. I want to visit in some detail the COVID-19 disease process because I truly believe this helps. I will try not to go into too much molecular detail unless there are people who are truly interested and we can come back to it at the end. But I want everybody to understand the principles of treatment and prevention of this disease by the time we get to part 3, in which we will go over vaccines, both in terms of development, review, and implementation, and then talk about what the new variants mean for the future of the pandemic. This is a graph I have used since last spring by Financial Times, which shows deaths worldwide due to COVID-19 on a daily basis. It is truly incredible to me that the United States is responsible for quite so much mortality. Now, is this in part because we are testing for the virus and are able to detect it? Well, we know that this disease is underreported in many countries, and that includes the US. However, even after adjustment for reporting rates, the US has a very high mortality relative to its population. The current situation, and this is from the New York Times because they have had some of the best graphics on this disease going for the past year. The situation right now is that while we had this massive super spreading event around the winter holidays from Thanksgiving in November through just after the New Year, in which people were infecting their families and dinner guests and fellow travelers, once the holidays were behind us, transmission rates really went down. Also in that same period of time, most parts of the country, even those that previously resisted taking measures against COVID-19, such as requiring masking or ordering public gathering places to shut down, many places that were very resistant to those policies caught up because in the heartland and in rural areas where it previously didn't make sense to people that this disease is quite deadly, by the time the winter wave happened, they were quite overwhelmed. There is not yet enough of a change in weather to say that we are exiting the winter transmission season. And we do know that the virus is slightly less transmissible in warm air relative to cold, but really the problem is that people gather indoors in the winter. And there is a limit to how much you can do with ventilation when the outside air is freezing. The unexpected cold wave that affected the center of the country last week may also rise to another small wave because many people were sheltering or evacuating and were not able to maintain social distancing. So we will see how this evolves. And finally, when we see the red line plateau out rather than continue to drop, we start to worry about the emergence of variants such as B117, which have been proven to be more transmissible. The pandemic has not affected all parts of the US or any other country equally. The Johns Hopkins University dashboard has a map of deaths by population by county. And the counties with the highest per capita death rates have not only been ones with pre-existing conditions such as heart disease being more common, but also counties where the vulnerability of the population is high for social reasons, such as low income, lack of education, long distance to medical care, or lack of advanced medical care, and also historic disparities based on racial inequalities and discrimination. The toll of this pandemic in the US is dramatically different based on your ethnic group. And this has been quite tragic to watch, both in the public sphere and as a physician. I take care of the population of the District of Columbia, where more than 2/3 of the city historically have been Black or African American. The toll of the pandemic on the patients I've known for my years here and that I've seen struggle in the hospital has been markedly different depending on which part of the city they come from. And some of this has to do with pre-existing conditions, and again, the social conditions that determine chronic poor health, such as heart disease and diabetes in our country, but also about access to care, fear of how much it's going to cost to come to the hospital, and fear of, in some cases, fear of authorities in general. When it comes to the risk of acquiring, in the US, acquiring COVID-19, we are not out of danger yet. So this map is based on how much testing is going on in your county and what proportion of the tests is coming back positive. And in December, as you saw, no matter where you were in the country except the middle of Vermont, you ran quite a high risk of becoming infected if you gathered indoors with other people. It is less dramatic right now, but transmission is far from safe levels, and this makes it a very difficult decision for municipalities about what kind of businesses should be operating and what kind of schools and classroom sizes are a good idea. This study came out going on 1 year ago. It is something that's been proven over and over in our experience. And I include this as an example for the mathematical modeling studies, which have informed some of our ability to keep up with this virus and try to stay a step ahead of it. What we know based on mathematical modeling of infectious diseases is until you have a population that is immune, that has herd immunity, or enough people are immune to whatever you are studying, that a new infection can't find the next host. Until then, if you keep introducing something that's highly contagious, such as the virus causing COVID-19, you will keep having outbreaks over and over unless you have strict public health measures in place. The number that determines how contagious a virus is, R0 or R0, roughly represents how many new cases each infected person will create if no public health measures are taken. So how do we get out of this? We have known for a while strategies that work, and there are extensive scientific literature reviews now about the importance of hand hygiene, masking, both for people who might be contagious and the people coming in contact with them, ventilation and changing how we work, where we work, but maintaining surveillance over what the virus is doing and being ready to take a step back, or use a circuit break terminology, if we decide that our previous level of activity is too risky. Vaccination and immunity is the piece that we believe is going to get us to herd immunity without losing millions more of lives in the process. So this is some of the, a really simple mathematical equation for how much of your population you need to vaccinate to protect people from becoming infected based on R0. So for COVID-19, which infects approximately 2 to 3 people per case unless you keep them masked and isolated, you want 60% of the population to be immunized or immune from prior infection. Now, if your vaccine is 100% effective and you vaccinate 60% of your population, you are there. If your vaccine is only 90% effective, you have to vaccinate more than 60% of your population. Now, when we talk about the virus SARS-CoV-2, we are talking about an entity that's thousands of times smaller than a human cell, and that invades it in order to take advantage and use it to reproduce in. Viruses are not sophisticated enough to have their own reproductive mechanism. So in the instance of SARS-CoV-2, responsible for COVID-19, it will use a protein on its surface called the spike to attach to a receptor, or sort of a lock and key model, on the surface of our respiratory cells. And once it's attached, it will use it and an adjacent molecule to merge, enter the cell, release its RNA or genetic material contents, and then it takes over our very effective human reproduction mechanism, which we usually use to make our own proteins, and instead we start making viral proteins, and as well as copies of the viral RNA. The virus then assembles itself and exits to infect the next cells. And this will remind people of your college biology, but when we say that mRNA is translated and becomes proteins, we are talking about essentially a code or a string of letters that, when interpreted by our cellular mechanisms, will create a chain of protein. The protein will then go through a complicated thermodynamic process and fold into a stable shape. The reason I am hurting you with all of these detailed diagrams, like my students, is that I want us to think about what altering that code means when it comes to dealing with variants. I also want to recognize that we don't yet have the computer technology or the machine learning technology to be able to predict exactly how genetic code will fold into a chain of protein and the final shape it will take. Those calculations are for now beyond us, and this limits our ability to know what the next evolutionary step for the virus may be. We rely on empiric data or gathering samples from what is already out there. And this is a more detailed view of the spike protein. So it's made up of 3 parts. If you break down each of these parts, we can identify its domains, and we can identify mutations in each of those domains that can change the overall shape just enough to alter how it binds to a receptor or interacts with our antibodies. So once it's in our airways, what happens then? Well, the first thing it does is, in the upper airways, it starts to break down the cells that create the lining of our breathing tract. Once it gets deeper into the lungs, it starts to break down the very delicate cells that compose our alveoli, our air sacs. And when they are damaged, there's a lot of inflammation, fluid is released, the lungs literally begin to flood in severe COVID. What this looks like on a CT scan on the right, this is a cross-section from a patient who had been on a ventilator with critically ill severe COVID for a long time. And what you see there is the heart is in the middle, and that looks okay, but all around it you see damaged lung, flooded lung, a big air bubble on the left where lung used to be and partially collapsed and is now filled with fluid. And on the left, I couldn't embed the video well enough to work, but one of my colleagues, Dr. Mortman at GW, created this 3D video that shows areas of inflammation and breakdown in the lungs of a COVID-19 patient. The virus can also affect other tissues. So the ACE2 receptor exists in other cells, not just our lungs, and that includes the heart muscle. So you've probably heard about young athletes getting myocarditis or heart inflammation from COVID-19. We also have known for a year now that people with pre-existing heart disease are much more likely to die of COVID-19. The heart may not be able to rise to the extra demands of dealing with severe illness. And the direct or indirect damage may be enough to overwhelm the system. And COVID-19 appears to be a very inflammatory, damaging process on the level of our microscopic blood vessels. It makes the blood more clotable, even to the point of causing major blood clots in relatively young people in a handful of cases that was reported in New York last spring, and that once we started looking, we started to recognize that this happens in a significant proportion of cases. This is some of the clinical data from the initial group of 41 patients reported from the hospital in Wuhan, China, that caught the world's attention with how high the rate of ICU hospitalization and death was. And what came out in some follow-up data that was shared almost exactly 1 year ago through the Centers of Disease Control at the first conference on viral infectious diseases that was scheduled to happen. CROI is normally an HIV conference, and I was very excited to present some of my HIV research there 1 year ago when the whole conference was shut down because it was supposed to happen in Boston, and Boston was having a major outbreak because of a different biomedical conference that had taken place just a week prior. So CROI was the first conference I know of to become virtual, and now this is how we work all around the globe. So some of the data from CROI that has proven itself right over and over again is that this disease is much more severe in older people, and the death rate above age 50 and then above age 60, 70, and 80 respectively rises dramatically. We don't know quite why people who have initially not so severe disease might still get post-acute COVID or long COVID symptoms. And I have some suggestions on this that are being explored in research as we speak. But there is a very strong interest in what the immune system does with SARS-CoV-2. So the initial layers of protection we all have against invading viruses, bacteria, etc., are the lining of our skin, our airways, our gut. Once those barriers are crossed, our innate immune system starts to put up a response, which is kind of a non-specific general inflammation. We have cells that we've had in evolutionary terms for a very long time. They include cells that will patrol, monitoring for anything that doesn't look right, debris, damaged cells, and start to clean them up. In the process, these cells use chemical signals that make blood vessels more permeable, so people start to leak fluid into their lungs and into whatever other damaged tissue there is. If you've ever cut yourself, you know that that area gets swollen. So imagine that happening to the lungs or to the heart. And then a little bit later, adaptive immunity kicks in, which is a much more sophisticated system that uses antigen-presenting cells to pick up bits of whatever the invading pathogen is, presented to the lymphocytes, which form an immune memory and which start to produce specific antibodies or molecules that will bind exactly to what was presented to them. Now, you have to picture this happening in three-dimensional space. And when a virus or a bit of a virus is presented to the immune system, the antibodies that are produced will bind to different sides of it, depending on which exact sequence your immune system happened to recognize. This whole process takes time, and about 2 to 3 weeks after exposure to a new pathogen, if the adaptive immune system kicks in effectively, you are clearing it. If it does not work as intended, if the person is older or immunocompromised or is receiving medications that suppress the immune system, this may take longer and be less effective. And then this is a graphic about when tests are likely to be positive. So molecular testing, PCR testing, or nasal swabs, those are likely to be positive within the first week or two of symptoms. And then some of them may continue to show bits of virus, which it's just picking up bits of viral debris for the most part. But at that point, your antibodies have gone into production and are also circulating, helping your adaptive immune system clear what's left of that virus. So we start to be able to notice antibodies a couple weeks after infection or immunization, and their levels decline over time depending on which class of antibody you look for. This gives you an idea for how doctors, researchers, and pharmaceutical companies have looked at treating COVID-19. So you can target all of these different parts of the viral process, and you have to think about where that fits with the patient's clinical condition. So most people who get COVID-19 will deal with it effectively in the first 2 weeks. They will have no symptoms or mild symptoms. This is the patients who never really go beyond the viral response phase, and they handle the virus fine on their own. However, the older people are, or the sicker they are to begin with, the more time it takes to clear the virus, and the more inflammatory process happens in that time, causing a lot of damage. So remdesivir, the intravenous antiviral medication that's in common use in the US, works best when there's some but not a lot of inflammatory damage, but there's still virus that you're trying to clear. It does its job by blocking viral replication and reducing how much more the virus will spread throughout the body. Dexamethasone, which is a steroid, can be used even after severe inflammation already started, and at that point people typically require oxygen, and if you look for different markers of inflammation in their blood, they may be going off the charts. And there is a range of immunologic medications. You may have heard of Actemra or tocilizumab, which block even that most severe inflammatory response, but it comes at the cost of impairing the immune system and prolonging potentially illness. So there has been a lot of back and forth in the medical world about what can we do, if anything, for people who are already in the ICU. The National Institutes of Health has this regularly updated, extremely detailed guideline to every treatment out there on COVID-19. It compares all the levels of evidence. For people who are not hospitalized, who have mild or moderate COVID-19, the Food and Drug Administration in the US has authorized the use of monoclonal antibodies or synthetic antibodies to help clear the virus before it even does enough damage to make someone go to the hospital. But this is how we make decisions in clinical practice. And as you see, by the time somebody is on invasive mechanical ventilation or there's a ECMO or essentially a heart-lung bypass process that we can use to keep people alive despite very extensive damage, by then not a lot of things work. Our ability to care for severely ill patients has improved dramatically throughout this pandemic, starting with knowing how to do no harm or not give patients things likely to harm them, and also for ICU staff and medical personnel to be able to work with highly contagious patients safely, resulting in higher quality of care. So this gets us to, how do we prevent this disease? And I have a picture of the first woman in the United Kingdom to be vaccinated against COVID-19. The normal system of vaccine development starts with basic research or test tube science and discovery of targets or molecules that you want to create antibody defenses against in your vaccinated person. There is a lot of work, years to decades of work, that happens before the vaccine is ever tried for human use. What helped us with COVID-19, the virus that causes it, SARS-CoV-2, is a very close relative of the first SARS virus from 17 years ago, which caused a major epidemic in East Asia and then was able to spread easily around the world until travel precautions and airport screenings were implemented. And it gave a big red flag to people thinking about national security, the future of international trade, and pandemic preparedness. There was a big investment in finding a vaccine against SARS in 2003, 2004. And then the virus went away because we were so successful with public health measures then. So there were no humans with SARS to test it on, and SARS is far too deadly for anyone to volunteer to be infected on purpose. So those preclinical studies, though, with laboratory animals were not forgotten. And that data was available when, in spring, different scientific groups started to look at vaccine development for SARS-CoV-2. It saved a lot of work, and then the adaptations that were made to make vaccine trials take slightly less than the usual decade were combined phase 1, phase 2 safety and immunologic response studies, and expedited phase 3 studies, as well as expedited production of the vaccines. So when the FDA approved the J&J vaccine today, if you look at the coverage, it says immediately 20 million doses are promised for production and delivery. Well, where does that come from? It's because the drug companies have, at their own financial risk, have been stockpiling the vaccine awaiting approval. And that's been happening throughout the past half a year. And in cases when the vaccine is not approved, they take that loss. But if they're confident in their product, it allows them to save months from phase 3 trials to when production would usually happen. This all still requires close regulatory review by world regulatory agencies. So the Food and Drug Administration in the US, the European Medical Agency, and the WHO have all been reviewing vaccine data. And when we think about how long do vaccine trials usually take, it's very hard to determine the efficacy of a vaccine if the disease you're trying to protect against is rare. So if I'm trying to develop a new measles vaccine, I really have to go look for places where measles is breaking out to even find enough people transmitting it. It was anticipated that clinical trials for COVID-19 would take most of 2020, but then there was a big rise in cases in the fall. Schools opened, Europeans went on vacation, Americans got tired of safety precautions, and the virus came back with a vengeance in the fall across many countries where trials were already going on. So phase 3 took a lot less time than usual. Now, in the US, Operation Warp Speed was a government and private partnership that was meant to make all of the above steps happen smoothly, in a coordinated way, and then have a plan for distribution. And these were some of the pharmaceutical partners. This is part of much greater global efforts on vaccine development. So I like this vaccine tracker from the Milken Institute that allows you to check on every vaccine candidate and see where they are. Some vaccines, such as the Russian Gamaleya vaccine, were released for broad use within their country before testing was formally completed under emergency measures. Others, such as AstraZeneca, Oxford, did trials that ended at different times in different countries, and based on which regulatory agency requires what type of study exactly, are at different places in terms of approval in different parts of the world. The two vaccines that closed the finish line fastest were both mRNA vaccines. So a quick overview of how we can make vaccines. So the live attenuated virus is the oldest, is one of the oldest methods, and you essentially house pieces of what you're trying to vaccinate against in a harmless virus, get it to take up bits of your COVID-19 virus, and then use the harmless virus to deliver just that piece of pathogenic material of interest into your person you're vaccinating. Inactivated viral vaccines have been around for a very long time and were traditionally used in ways that essentially chemically inactivated or by use of heat denatured the virus. And in inactivated vaccines, there is no longer a chance that the virus will cause infection in the person you are vaccinating. However, those vaccines can be less effective because the process of chemically inactivating or heat inactivating the virus damages it and can break the structure you're trying to defend against. And then the antibodies that are formed aren't exactly what is needed to protect against the live virus. Subunit of vaccines are more modern. You synthesize a piece of viral protein and couple that with an adjuvant, which is a biochemical entity that kind of triggers a stronger immune response, and give that. And the mRNA vaccines are the newest technology on this slide, but have really been around for a decade or more in different studies. They involve only giving a piece of genetic code that encodes the viral protein, letting the human cellular mechanisms translate that into the viral protein and take it from there. So with the mRNA vaccines, they're kind of the fewest components and the shortest distance from knowing the genetic code of the virus to having a vaccine for it ready. mRNA vaccines were proposed as a rapid adaptive technology that could be used to rapidly respond to a pandemic. And COVID-19 has at least proven that premise right. So the two leaders in mRNA vaccine development were Moderna and Pfizer, both partnered with other entities. And they had to solve a couple problems. One was how to deliver the mRNA, which is very fragile and normally decomposes in a matter of hours. And then to determine whether there would be any unintended inflammation, because this is a new technology, and to figure out if the immunologic response would be powerful enough. The results from the trials have been spectacular. These are by far the most effective vaccines we've seen. So in the Pfizer phase 3 trial, more than 95% efficacy of the vaccine after 2 doses was demonstrated, and after 1 dose, over half of the participants stopped getting ill. The results were consistent across different types of participants in terms of their health, their age. Now, certain groups were excluded from trials, and I'll get to that in a slide or two. And then in terms of side effects, the most common were pain in the arm, fatigue, headache. 16% had fever after the second dose. I can personally report I was one of those 16%. And about 9% had symptoms severe enough that they had to take a day off, not go to work, or take some medication, such as Tylenol. Now, the vaccine was authorized in the US in December. Moderna was close behind with very similar results, 94% efficacy, slightly higher efficacy after the first dose, and very similar in terms of side effects. Now, while pregnant women were not allowed to intentionally enroll in this trial, 13 people who enrolled in the Moderna trial became pregnant during it, or found out they were pregnant during it. And those were small numbers, but there were no safety signals or safety concerns among these 13 pregnancies. And then this is a freshly published report out of Israel, which has to date vaccinated more than 1 million people. And they were able to use a large nationwide health database to look at the real-world results. And what they reported was very similar efficacy to what was reported in the trials. So I'm showing you the types of health conditions that the real-world people had in Israel, as opposed to the slightly healthier, more uniform people you recruit when you're trying to make your product look good in a trial. And I especially call attention to the number of people who were smokers, who were obese, and the rising number of people who have received the vaccine and were pregnant. And the vaccine has, again, proven itself to be exceptionally effective at preventing disease, including severe and deadly cases. And this is in a real-world population, which will never show results quite as good as a carefully selected trial. But this really holds up to scrutiny. And then the mRNA vaccines, because of increased attention to safety concerns, I wanted to share the CDC reports about severe allergic reactions. So all of the allergic reactions that were severe in these patients occurred not in the trials, but once the vaccine was in wide use. The trials were large enough that, statistically speaking, you could detect an event if it happened one time out of 100,000 people or more frequently. To detect really rare events, such as things that happen a couple times in a million, you really need real-world post-marketing data. And this is why the FDA continues to monitor vaccines after they're approved, the FDA and its respective international counterparts. So what the monitoring data on the Moderna and Pfizer vaccines show is that a few times in a million, people will have a severe allergic reaction. And this is thought to be not due to the mRNA, but due to the preservative, so that people who have this allergic reaction should not have another mRNA vaccine containing the same preservative in the future. And the preservative is there to stabilize the mRNA, which is otherwise quite fragile. Outside of these severe allergic reactions in which people had airway closure or difficulty swelling, and difficulty breathing, and needed immediate medical attention, outside of that, the vaccines are proving themselves quite safe in widespread use. However, I think we need to let people know appropriately that their arm will likely be sore and that they may feel quite tired for a day or two. We also are learning more about rare events that are not life-threatening. We've heard some of our patients report that their arm was fine for the first 2 days and then for some reason got sore 3 days later. We've heard of a couple people having no fever until a week out. And some of it may be a delayed immune reaction. But whenever those occur, there is a reporting mechanism, and the CDC has an app that people can use to report their own symptoms in addition to what their doctor is reporting. So these are some CDC recommendations, and I'm happy to get back to this at the end. So to move on to the adenovirus-based vaccines. So this is a weakened viral vector. The adenovirus normally causes cold virus symptoms or no symptoms at all. And it has been spliced with a gene for the spike protein of SARS-CoV-2. And then that goes into the person. And ways in which it's thought to be better than mRNA vaccines are, for one thing, it's less fragile. It doesn't need to be kept in super cold conditions. It can be stored in a normal or industrial freezer and refrigerated for longer without losing potency. It can be, the vaccination can be accomplished through one dose rather than two, although it may be more effective after two. There are several studies ongoing with the AstraZeneca vaccine. And it's a very well-established method, which means that plenty of facilities have the equipment to make these types of vaccines. But the vaccine production takes time and the quality testing takes time. There are more moving parts involved. So you have probably seen some headlines around why we don't have the AstraZeneca and the Johnson & Johnson vaccines in the US yet. Johnson & Johnson was just recommended for approval today. AstraZeneca data is in review because in that case, they had very different efficacy results from different countries. Now, this may be because of local variants in the virus, and this may be because some of AstraZeneca's trial designs differed from country to country. So in the US, the FDA is taking longer and waiting for results of the US-based trial. The overall efficacy results, though, still show more than 70% effectiveness in preventing COVID-19. And if we're choosing on a large scale between no protection and 70% protection, I think we all know what makes sense. And then there are protein-based vaccines, which are taking even longer to perfect, but Novavax and Sanofi Pasteur are some of the leading companies, and those include synthetically produced protein. It can be also produced in large scale with existing equipment. It can also be more stable in storage and transit, but it had, at least one of them, the Sanofi Pasteur, had somewhat limited ability to create immunity in older people, and that's who we're really trying to protect here. So Sanofi Pasteur took a step back, reformulated it, and is retesting it in its phase 2. Novavax may be closer to the finish line, and we will continue to learn about new vaccines. Something that's been a challenge in the US is communicating all of this in an organized way in the public sphere, and striking that balance between skepticism about new vaccines. Scientific agencies are skeptical and need to see very high quality data to approve anything, but also getting the public's trust and sharing that once something has passed scientific peer review, it should be trusted broadly. Key figures in leadership play a large role in this. So if we're ever going to get to herd immunity, I'm showing kind of for comparison what the herd immunity level is for some other familiar diseases. If we'll ever get to a herd immunity of 60 or 70% or better, here's what we have to overcome. For one thing, there's organization. How do we vaccinate so many people and who goes first? So in the US, we've prioritized healthcare personnel and residents of long-term care facilities or nursing homes who accounted for over 40% of the mortality from the pandemic. And then we've since then started vaccinating essential workers, so teachers, public transit drivers, sanitation workers, and people who were 75 or older. And then in phase 1C, which some areas have moved to, we're vaccinating middle-aged people, younger people with medical conditions, and essential workers not on the first list. What's been a problem in the US, it's both a strength and a weakness of our system, is that there's a lot of independence between the states and what they do. So on one hand, states have been able to craft their own strategies as to who goes first and where. On the other hand, it results in very high disparities and sometimes doesn't correlate with where the hardest hit areas are. Overall, we're at less than 7% fully vaccinated as a country. And these are the 2 mRNA vaccines. They both require double or 2 doses separated by 3 to 4 weeks. J&J, as of not very many hours ago, is about to join them and has been stockpiled. When we talk about vaccine distribution, I just want to show an illustration of Washington, D.C., which is divided into wards. You can look at any major city in the US, it will look similar, whether you're in Florida, New York, or California, or Chicago. The areas of the city that were hit the hardest by the virus, that's in green, are some of the areas that have been vaccinated the least to date, and this is among eligible people. So it does not reflect the age of the population. It reflects of people who are eligible to receive the vaccine. Now, some of it may be a little bit skewed because there are a lot of healthcare workers who live in Ward 3, but overall what this reflects is economic and social disparities, access to care, ability to use online registration, such as the website on the right, and some deeper barriers that have to do with where people of color live in DC, which is wards 4, 5, 7, and 8, and 6 predominantly. So one of our local challenges has been bridging the historic distrust and legacy in which the US medical system has not treated people of Black heritage fairly. People who are older among our African American patients remember clinical trials that were done on African American patients without their consent or without giving them access to the medications that resulted from those trials. And there's a bad history between clinical trials and people of color across our country. So we've had to be very strategic and sensitive and to work with community leaders. We've had help from some of our very inspiring trial participants. Helen Cooper is a New York Times journalist who is quite well known for covering Ebola and other global health crises. And she publicly shared her experience in getting vaccinated, as well as what led her to go through and participate in the trial. And we've been working hard to overcome some of the same trust and access issues when it comes to distributing the vaccine. So a little bit more about why people in the US don't want to get vaccinated or might put it off. So I mentioned race and ethnicity and history. I'm mentioning women because there is a terrible rumor going around online about the vaccine causing infertility. It is not based in reality. There have been studies that disprove it. And there is a lot of attention being paid to the safety of the vaccine and how it's doing in pregnant women or women of reproductive age. However, once misinformation is out on the internet, it takes time to counteract it. Other things that improved people's trust in the vaccine were due process of FDA approval, the question of how efficacious is it, so people are more likely to go through and get vaccinated if the vaccine has high efficacy, if they're promised longer duration of protection, and if the rate of side effects that are major is low, along the lines of 1 in a million. So all of this bodes well for the mRNA vaccines, and we hope to do a lot of the same communication if the adenovirus-based vaccines hold up similarly. And these are some of the leading voices in how to communicate public health in the U.S., including some public communicators like actor Alan Alda, our scientific leaders Tony Fauci and Rochelle Walensky, but also ordinary healthcare workers, like the first nurse in New York to get vaccinated, and people who have survived other pandemics, survivors of Ebola, like medical workers who volunteered overseas, and survivors of HIV and AIDS from the 80s and 90s that can speak firsthand to the importance of trust between the scientific community and the people most affected, and how both sides have to work at it. And then we have a lot of ordinary physicians, academic physicians, but some people in private practice. This is a sampler of GW affiliated folks, including another scientific celebrity, Dr. Hotez, who is now leading vaccine research in Baylor in Texas and writes quite eloquently about global health and inequalities in health. We have a DC Medical Society, which has done a training for physicians who wish to meet with community groups to help bridge the gap and make people feel more at ease with the vaccine and answer some very legitimate questions. And then we get to the variants, which have really thrown a twist into our system. So the reason I bored you all with how proteins fold is that when the genetic code changes and the folding changes, that influences the shape and the function of the virus as a whole. So in green, there's a piece of spike protein called receptor binding domain, and mutations in that domain tend to really change how well it binds to the human receptor. Based on mutations in that area and elsewhere in the virus, we're able to define lineages or kind of a family tree for the virus as it has moved across the globe. Now, different viral variants and mutations have been with us since the very beginning of the pandemic. There is a mutation called D614G, which was noticed first just over a year ago and has become a dominant mutation worldwide. And it is thought to make the virus more transmissible, and it's thought to be part of why the epidemic hit Europe and the US harder than it did Wuhan, where it first emerged. That mutation was acquired in the process of the virus spreading and made it more transmissible. Some of the newer mutations include in a UK family branch, there are mutations that make the virus more transmissible and present in higher levels in the airways. It appears to cause more cases in children. It appears to be slightly higher in mortality compared to the general virus in the UK. And it appears to be doubling in number in the US every 10 days or so, although our ability to do surveillance for specific variants is a little bit limited compared to the UK. In South Africa, there is a lineage called B1351, which has some very specific mutations that may enable it to evade immunity, both from prior infection and from vaccine infection, and is causing a lot of concern. So South Africa was committed to a mass vaccination drive using AstraZeneca's vaccine. It has put that on hold after a small study showed that immune protection dropped to only 22% of pre-mutation levels. So I understand South Africa is now redistributing its AstraZeneca stores to other countries in Africa that don't have as much of this variant, and that they are now planning to use the Johnson & Johnson vaccine, which seems to function better against their variant. And in Brazil, we have a very frightening story in the city of Manaus, where over 70% of the population was considered immune after a major outbreak happened there in early year in 2020. And Manaus in the winter went into a very large second wave that was dominated by this new variant P1, which shows that at least with natural immunity, they're able to evade it. There's a couple variants of concern being tracked across the US. I'm going to very quickly show that even when antibody levels and binding to the new variants drop in people vaccinated with the Pfizer or Moderna vaccines, they don't drop all the way to nothing. They are reduced but not nullified. And this is key because we want to get ahead of this virus in terms of our vaccination strategy. I know we're out of time, so I'm going to wrap up quickly. We'll leave monoclonal antibodies unless someone has very specific questions for them, but they are similar to antibodies from immunization and vaccination in that the South Africa and Brazil variants may evade them. And there are very...
Dr. Hannah, excuse me, I have a question. I think we have been going wonderfully well. I think we learned a lot. I think I have too many questions, so I want you to, at this point, take up questions so that we can satisfy all the people who have been asking the question. If you don't mind, I think at this point, we are ready for the questions, and I'm going to introduce Dr. Arnab Ghosh. And Dr. Ghosh, please take it over, and there are a lot of questions for Dr. Hannah to respond. Thank you so much. Hannah, you did really wonderfully wonderful. I learned a lot, and so I think the audience. Dr. Ghosh, you are on for the questions. Please, ready. Thank you, Dr. Ghosh.
Yeah, thank you, and wonderful presentation, Dr. Axelrod. We had a little COVID webinar a month back, actually a little more than a month back, and at that time we had barely 2 vaccines approved, and just to think, within a matter of 7 weeks since we had that webinar, we now have in the US 3 approved vaccines. In India, we have 2 approved vaccines, and they have gone on to phase 2 trials. And just to think of the science, which has, last year at this time, we were just seeing this disease spread, learning a lot about this disease and getting thoroughly scared about how quickly the pandemic has spread. And this spring, this winter and this spring, we have been primarily getting the good news about it, about the development of vaccines. And it's really fascinating how well the science seems to have worked. So let me start off with a few questions that I got on the chat and a few more that I have been getting over the emails. So let me start off with a question that Ms. Belvarier just talked about. And she was asking, which vaccine is better? Do we know that yet? We have 10 vaccines now. You talked about at least 3 of them approved. Which is better?
The short answer is the one you can get. Now, we're not anywhere in the world, we're not anywhere near being able to pick and choose, at least not in terms of strategy. That said, as more vaccine doses become available, that does become a question. We may wish to use our highest efficacy vaccines, the mRNA vaccines, possibly for people who are older, who need the strongest levels of protection or the highest certainty. We may want to use them for healthcare workers. The Johnson & Johnson vaccine that was just authorized, we still have some data that will come in that will show if a second dose will make it even more effective. The AstraZeneca vaccine, as I said, there are ongoing analyses from data around the world. We are going to need to adjust our vaccine selection based on new variants. South Africa has demonstrated how this can happen in real time. So we need good surveillance and intelligence on a molecular level about what the virus is doing. So my last slide, we were very nearly at the end, but I don't want people to lose hope just because the virus made a move to evade our antibodies. Viruses do that. That's how they survive. We are a learning species and are able to adjust our vaccine supply. We have to finesse some of our processes for making new vaccines. And there will be new updates to all of these vaccines from year to year, I believe, similar to how we do with the flu.
I see. And another question that I got was, so Johnson & Johnson has a single dose. Moderna and the Pfizer vaccine seem to have 2 doses, one 3 weeks apart, one 4 weeks apart. Who decides these things and how do they decide these?
Yeah, great question. So taking it back to phase 1 and 2 studies, when you choose a group of maybe fewer than 100 volunteers and you measure their antibodies after dose 1 and after dose 2. And then the scientists in each of those development teams made a judgment call about, is that adequate antibody level after the first dose and does it last long enough? And then when that's translated into designing phase 3 studies, when you say, I am going to recruit 20,000 people and give them 1 dose of vaccine and ask them to come back 4 weeks later for dose 2. Well, where am I doing this trial? Are my patients able to come back? Where do I plan to use this vaccine in the future? Will I be able to track down every person and guarantee they'll get a second dose on schedule or not deviating far from that schedule? So that's where we will be interpreting data for a long time. There are some studies to see if the AstraZeneca vaccine is good enough after the first dose, if the Pfizer vaccine second dose can be delayed to 6 weeks rather than 3, if getting half of your population to 50% immune is better than getting 25% of your population to 90% immune. There's a lot of modeling going on like that.
Okay. We often come across these reports that even after a month of getting both the vaccines, completing the vaccination course, people end up becoming positive. What do you think about that? And also, sorry to interrupt, but the other part of the same question was, what is the reason that some people tend to get sicker after getting the shots, but others are completely free? Like you, for example, said you were among those 16% who had a fever. After the first dose, I felt like I got sterile water because I had absolutely no symptoms. What decides this?
So 2 excellent questions, one about efficacy, one about safety. So the vaccine may not be able to prevent every last infection because coronaviruses are extremely good at entering our airways. And again, they may be able to change their surface proteins just a little bit to do it from season to season. This is why we've all had the common cold so many times in our lives. But what we don't want is severe illness requiring hospitalization or that can result in death, or illness that can cause long COVID symptoms. So if our vaccines are good enough to prevent moderate to severe illness or prolonged illness, that is good enough. It does seem that the vaccines work that way, and it also seems that they reduce the viral loads in people's airways to potentially make them less able to transmit to others if they get infected after they've been vaccinated. And that's because, think about the virus coming in a person who's meeting it for the first time, it's advantage virus. It gets a first start. The immune system has to learn from scratch. If you've been vaccinated, even partially, your immune system has the T cells primed for it, has the antibodies pre-made. It starts blocking the virus as soon as it arrives. So if the virus was going to strip your entire airway on its way in before you got any immunity, and instead you get a slightly runny nose that goes away in 3 days and don't infect your entire classroom or family, that's a type of victory. if we can get COVID-19 to be about as significant as the flu every year, I think we'll be in good shape as a species. Now, about the side effects, we don't really know. We think that robust side effects may be related to a robust immune system response. So young people in the Moderna and Pfizer trials tended to have more side effects than older people. But the vaccine still worked in older people. So interpret that.
And what is probably notable is that lots of people have died from COVID. I don't think anyone has really been clearly dead from vaccinations that we know of.
No, no one has died from the vaccine with any of the vaccines that we know of. Again, like there's a limited amount of what we know about, let's say, the Russian vaccine,
Right.
but the ones that are publicly reported.
But not the ones we get in the US.
Right, not the ones in the US. Like thinking about the US legal system, everyone sues everybody for everything here. Vaccine companies really don't want to get sued.
Okay.
So they're paying a lot of attention to post-marketing data. And the other piece of it is a lack of side effects from a vaccine doesn't mean it didn't work, because those may be different branches of the immune system that are involved.
Okay. Perhaps I could take one last question, and I think that's really important to many around here. That is it safe to take alcohol after taking the first and second shots?
Oh, that's controversial. No, that was not addressed in the clinical trials. We really don't have data on that. We, after any vaccine, we warn people that they may feel lousy. I didn't just get fever after COVID-19 vaccine. I get it after every flu shot I get every year. So I know I'm not going to ingest anything that may make me feel like I have a hangover the next day when I anticipate not feeling my best to begin with. The other part is, for some people, side effects may include dizziness, being unsteady on their feet. So especially if they're older, we advise them not to drink alcohol for a couple of days after the vaccine.
Thank you. That was very thorough. I think we have reached the end of the allotted time. Thank you so much. This is very, very informative. And that's the chat messages I'm getting here as well.
Thank you so much, Dr. Ghosh. You did it very well, and we tried to answer as many as question could be. I think we went it along. I apologize, but I think we learned a lot. I would request our president of the chapter, Dr. Shivenderji, and Vice President Vimal Gorju, spend a few minutes and say a vote of thanks to all of us. Thank you. Unmute yourself, Vimalji. Thank you.
Vimalji, go ahead.
Go ahead, Vimalji. Go. Yeah, both of you.
I'm going to go, okay. Good evening, ladies and gentlemen. It's my great pleasure to thank Consul General of New York, Honorable Randhir A. Jaspal, to join us as the chief guest, and his generosity as our host for this event. Dr. Hannah Axelrod, a presentation was excellent, and I learned one thing new, that there is something called COVID Intelligence Unit, which I was not aware of it, and she is the co-director of it. We appreciate your expertise in this field of vaccine. Our thanks go to Dr. Arnav Ghosh to coordinate this event and help us in Q&A. Dr. Thomas Abraham as an advisor and founder of this chapter. Without his help, the chapter wouldn't have existed. And of course, Dr. Asha Samant has been the force behind this event. Our special thanks go to Vijay Garg of Indus TV for streaming this event, and Chitran Belvaria for providing technical support for this evening. We are much obliged to all the media groups for their unwavering help. They are Indus TV, TV Asia, Parikh Worldwide, Media, Indian Eye, UNN News, PTS Punjabi, Radio Zindagi, and Divya Bhaskar. Finally, I thank all those who joined us this evening and those who asked questions, and to make it a more informative and interactive event. Now it is my privilege to introduce our president of the chapter, Shivinder Sofat, CPA. He is a real New Yorker, very resourceful, and has a great skill to contact. Without further ado, Shivinderji, over to you.
Thank you. Randeep, Dr. Hannah, very informative presentation. I have been watching the chat all along. Everybody was so appreciative. Learned a lot of good things here. Thank you for that. And thank you everyone for joining. A special thanks, which we missed to do earlier, to my friend and elder brother Rajiv Bhamri for sponsoring this event. As Dr. Thomas mentioned earlier, we are getting sponsorship for community feeding program, and whenever we do events, we seek out sponsorships, and which we ask people that if they have a specific purpose. And Dr. Rajiv Bhamri has sponsored this event and advised us to use it for community feeding program. Thank you for that. He has been always helpful with his media connections with various media, Indian Eye, TV Asia, Radio Zindagi, to help us promoting our events. Thank you for that. And really appreciate the whole GOPIO Manhattan team. Without their all support, we couldn't have done all these events in short period of time, which we have done. And next event, which we have few next events coming. The major one in March is the Shaheed Divas Martyrs Day event, which is in the memory of the martyrdom of Sardar Bhagat Singh Ji, Sukhdev Ji and Rajguru Ji. And we are going to do that program also in partnership with Consulate and few other organizations like Bharati Vidya Bhavan and Jhilmil in New Jersey. And we look forward, we will share that information. We will look everyone's support and cooperation in that for that event also. So thank you all. It has been a long evening for everyone, but it was so informative. It was very timely. Thank you for that. And Dr. Aruna, thank you especially for bringing this up for our chapter, that whatever you have added by getting this series done. And he is already planning for not only COVID, but beyond it. He's already planning few other things which we are planning to do on either on mental health or due to this COVID, and also the whole food plant-based diet, those kind of things. We will keep on bringing more to the community, which is helpful for all of us. Thank you all. Dr. Thomas, do you want to share anything else?
No, I think everything is fine, looking good. Dr. Axelrod was excellent. A lot of good information, which we never get it from other sources, but this was directly from the source we got all the information. Thank you. And Dr. Asha Samant did a great job in putting together this program. I also wanted to tell that in addition to what Shivinder, our president, mentioned about the program on 23rd, we have another program which is being organized by GOPIO New York on March 28th. Some of our GOPIO New York officials are present here. Lal Motwani, Bina Satapati, I see right now. That's going to be a Holi celebration on March 28th. Holi is on March 28th. So please do join for that. You will get the information soon. And I did mention in the beginning that GOPIO was formed by the initiative of the National Federation of Indian Associations, and its president from Los Angeles is also here. Welcome Ajay Dubey. He is the current president of the National Federation of Indian Association. Thank you for joining us.
Thank you once again, Hannah. You were wonderful. You really did very well, and we are all thankful to you. Thank you so much. Thank you.
Thank you so much for your patience and for inviting me, and my very best regards. Stay safe, everybody. And I hope the vaccine does not make everyone's arms too sore.
No, we did very well. I already got my 2 doses.
Thank you. Thank you, everybody. Thank you. Good night and safe drive, safe home.
Thank you.
So, ladies and gentlemen, that has been a live stream, including our chapter from GOPIO Manhattan and that presentation on the COVID-19. I hope you've enjoyed that. And with that, it's time to say goodbye. So until Monday, it is goodbye from me. Thank you so much for joining in. Enjoy the rest of the weekend and remain safe.